Greetings. Let's go over 3.17 from the homework. Scores on stats finals. Below are final exam scores for 20 introductory statistics students. And we're just going to do part A of this problem, which is the how do we use the 68, 95, 99.7 rule to determine normality. Okay, so to do that, what you're going to want to do is set up three intervals. The intervals that you need to set up are going to be x bar minus s to x bar plus s. You need to know what that interval is, and then you're also going to need to know x bar minus 2s out to x bar plus 2s. And then last but not least, you're going to need to know x bar minus 3s, there's a pattern here, to x bar plus 3s. Okay, the thing to notice is that each of these correspond to a particular percentage. Okay, so here, when we're at x bar plus or minus 1 standard deviation, that's 68% of the data should fall in that interval, according to the 68, 95, 99.7 rule, right? And then between plus or minus 2 standard deviations, we should be seeing 95% of the data. And out at 3 standard deviations, we're pretty much always going to see 100% of the data. So it'd be 99.7%. That's a 7 right there of the data. Okay, so what we want to do is we want to calculate those actual intervals. And then once we've done that, we're going to come back up here and take a look at our data and see if the data intervals fit. In other words, do the numbers in their fit. Now they've done us a couple properties here. First off, they came in and they sorted the data set for us. That was really kind of them to do that. And then they calculated our mean and they calculated our standard deviation. But just for the sake of completeness, let's say they didn't do that. Let's just say, okay, what is the real world? And they hadn't done that for me, okay? So then what I would have had to have done is come into my calculator, gone to edit, and it would have had to have entered all of that data. Okay, so I've done that. I go ahead and done the push up and I've entered it into L1. And let's say for whatever reason, let's say you didn't notice that if you had to enter it in row wise to get it sorted and you entered it in column wise. Pretty common method for entering data is to enter it in column wise, and you go, crud, I want it sorted. Well, no worries, because if you go to stat, what you see is one of the first things in the editor is sort ascending and sort descending. So you have edit the data, which put it in, or you can sort it ascending, you can sort it descending. So let's say we want to sort it ascending. I would just come down to option number 2. I would select that. And now I need to tell it which list do I want to sort. Now here's the beautiful thing, is that 1, 2, 3, 4, 5, and 6 are list L1 through L6 as a second function. In other words, I want to get the list 1. All I have to do is hit second and the number 1, and notice it pastes L1 right in there for me. Okay, good form, always close your parentheses off, have balanced parentheses, hit an enter, and it'll say done. And what it's done is gone in. Go back and take a look at it now. It didn't change anything because it was already in ascending order. But if it hadn't been, it would have sorted that. So let's show, just for the sake of completeness here, let's show what sort descending does. That goes from high to low. So if I went sort descending, and I put a second and an L1 in there, and now I go back to stat, edit, and you'll see that I'm going from high to low now, okay? All right, one other thing, what if I need the mean of the standard deviation? Well, don't forget that you would go stat, calc, one of our stats, L1. If you're on an older calculator, the default is L1, or you can just type in the L1 there. As we just reminded ourselves, is that 1 through 6 were those lists. And bada bing, bada boom, yes, they did not lie to us. The mean was 77.7 and our standard deviation was 8.44. Again, remember we're using samples here. These are not population values. Okay, good. So enough with the calculator. Let's get back to our regularly scheduled program here. All right, so how do I go about calculating these intervals? Okay, well, it's a little bit of arithmetic. I'll do the first 2 for you. You get to do the third one. I'm not going to do all the work for you here. So I'm going to come in and I'm going to say, okay, so this is going to be what? This is 77.7 minus 8.44 out to 77.7 plus 8.44. Okay, and then if I clean up that arithmetic, that turns into the interval 69.26 out to 86.14. Okay, so now according to the 68, 95, 99.7 rule, 68% of our data should reside in that interval. So let's come up here and take a look. So 69, okay, so it starts here at 71. So I'm going to make these brackets. Let's make these parentheses red so we know which ones I'm talking about here. So, and then let's see, going up 88.14, that's going to come up to this number right here. So all of those numbers between my red parentheses here fall into that interval. So let's do a little bit of counting here. 1, 2, no, I won't count that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, let's count one more time, make sure I got them right, because I'm not very good at counting sometimes. So that's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so what that says is the percentage of data that fell in that interval was 15 out of 20. Remember that we have 20 data points in total. Okay, that's where the denominator came from. So let's get our calculator back out here for a moment. And we take 15 and we divide that by 20. We get 75% of the data. So a little more than what was predicted, but not totally out of line, okay? So let's take a look at what the next interval would be. So the next interval is going to be from x bar, which is 77.7, minus 2 times 8.44, out to 77.7 plus 2 times 8.44. Okay, so that interval, once we do the arithmetic, is going to be 60.82 for my lower number. And then my upper number is going to be 94.58. Okay, so if this distribution is approximately normally distributed, the prediction is that 95% of the data will fall in that interval, okay? So let's do that interval in, let's do it in magenta, okay? So this will correspond to what I do up here. Okay, so 60.82, the 57 doesn't fall in there, and then up to 94.58. So yep, that 94 does fall in there. So only one of the data points doesn't fall into that interval. So in that case, that's going to be what, 19 out of 20? Or if we go back over to our calculator and say, okay, what's 19 divided by 20? Now look at that, came out exactly 95%, right? Or 95%. Okay, now I can guarantee you, you're going to do this part, okay? So like I said, I can't have all the fun. You've got to have some of it too. Okay, so the last thing you need to do is calculate for me the last interval here, but I can guarantee you that that last interval, do an orange here, is going to cover all of the data, okay? We'll have 100% of the data there. And notice 100%, once you round off 99.7, works pretty well. So when you respond to this question on the homework, you do need to give these three intervals, all three of those need to show up in your response, along with the corresponding percentages. So the 75%, the 95%, and it's going to be 100%. I'm not going to lie to you, okay? But you can put it in there for me, okay? So all that needs to show in there, and then you need to analyze it. You can't just say, they say, how can you decide? Tell us how you made your decision here. And these numbers, they fall well within reason of the 68, 95, 99.7 rule to consider this distribution as being approximately normal. Okay, there's more to this problem besides this. I think the rest of it's pretty well covered by the other additional video that's here. So watch that second video, post questions if you need help, and we'll see you around on the flip side.